Uh-oh, my computer's telling me I'm running out of storage space. Quick, let's do this quick because it's going to run out really quick. What do we get here? 68K, it's got to be up here. Hurry up, man, that video's going to quit any moment. Maybe open. I got to stop the video, I got to fix my computer. I'll see you in an hour or two. Okay, my computer's all healthy again, and in the meantime I relocated the speaker wires out from up in this area where there could be some kind of feedback thing going on, maybe. They're out here now. I can't imagine these are going to be a problem. So we're going to turn it on, we're going to see what happens. I measured the two resistors here, which I just kind of discovered somehow. I'm sure I measured them before. They both measure exactly correct. So the grid leak resistors, probably what they are, they're fine. But certainly when I put this here, they make a big difference. Let's switch it on and see if this by some chance did something. Are we ready? There we go. The last time I operated this, there was a period where it was perfect. No hum, no squeal. Pop, pop. Again, a pop and a pop. And I just think it's these two tubes settling into their operating spot. That's right, I did those crazy voltage tests where you keep repeating them and they just come different results. Interestingly enough, when I think about it, it's half. So it's like 15 volts or 30 volts. That's kind of interesting. So she's running now. I hear virtually no hum. But I certainly hear the squeal. So I'm going to put the scope on where the squeal oscillation appears to be. And I'm going to put that capacitor in there and see if it knocks everything out. Even though I think if I let these warm up longer, maybe that squeal will go away on its own, but let's fool with it. So I'm going to ground it out like this. Switch my fingers here. So I know what happens here for sure. I'm curious about the oscillations in the other part, but let's start here. Okay, I'm going to put this on the screen. DC here. Okay, and I'm going to flip you to the other camera. Just a little bit of a better view of things. And I'm going to stick that capacitor to drain out the whatever it is. And look at that. It doesn't do anything to that. It changes it. So I'm having trouble holding this on here. Here we are. So that doesn't do it. So just alternate places to put this capacitor. So the capacitor is not in now. It's here in my hand. And sorry about that. You could have been watching that excitement there. The squeal is gone. Hum is here. Squeal is gone. Hum is here, but the signal remains on the scope. I've done it again. I'm forgetting which view it is that you're seeing. Okay. Well, I have to assume that that oscillation should not be there. That is not intentional. Voltmeter. So the hum disappears when I touch certain grids. touch those the grid to plate connection in the preamp tubes. It's supposed to be 32 volts, I think it is. Half. 30. That's almost correct. So that's getting up towards a volt on there. There shouldn't be anything on there. Any voltage that I'm measuring right now has to be a voltage generated back from the grid, and that's what I believe I'm saying. This effect used to be visible over here. 0. 0. Get a better look at the voltage here. What's going on? What happened on the scope there? I wasn't really watching. Bigger. We put in this capacitor again. What we hear disappears. Son of a gun. I can't be sure I'm getting it really on there. I just knocked it right out before. Son of a gun. That certainly didn't knock it out now. This is inconsistent behavior in these circuits. It is crazy stuff. Look at that. There's 3 volts on there, but from the lead here. There's a quarter of a volt there, and these ones are sitting at 0, almost down where they should be. Holy schmoly! After all this, I am still such a dramatic difference. It's the same point on either channel. Well, talking about feedback, there's feedback right from the output, from this yellow wire to here. There's feedback over here. The purpose of the feedback is to correct for differences between the signal reaching the speaker and the signal being presented earlier in the amplifier. And the feedback is sensitive to those differences. Can I put it that way? And will remove the reduce the differences a lot. The difference is a distortion. The output's not the same as the input. The feedback also reduces the output a little bit, so it costs you a little bit, and that you need a little extra power to do the feedback thing while you're feeding the speakers. Not much though. Oh my gosh. How much effect is this having? Zero effect. Well, I'm just totally at a loss here of okay, a couple more experiments here. You know, if you don't know what to do, just do something. So I'm going to pull the two preamp tubes out. Now, why is it the last time I operated the amp yesterday, for an extended period, I had one tube not as hot as the rest. And even as I experimented and swapped tubes, same thing. Today, it's not the situation. Man alive. Okay, turn the power on, Jim. Quite a bit of staticky sound here. So this may change the input impedance into the output tubes by pulling this tube out. So in a sense, the grids here are now running, kind of running like antennas. Nothing there. Nothing there. Nothing there. Nothing there on the meter. Pull this tube out, and this voltage disappeared. Oh, I'll take that back. Well, that looks like a leak, the way it's slowly building. There's nothing, see, here's the thing. There's no supply voltage to this pin except from the grid. Let's assume the grid is positive with respect to the cathode. You know what? That's a measurement I failed to make all the way along here, is to check the cathode to grid voltage to really see what the bias is on these tubes. That's a bad mistake. Cathodes are here. Even touching the cathode makes a difference. And then the cathode to grid voltage. Now, how can the grid have any set voltage? So minus 10 is what this suggests on this tube. We have minus 10. Sounds pretty healthy to me. I'm going to try the same thing over here now. Should be the same. Should be the same number, I think. Minus 11. Be a little higher here. Okay, minus 11. Now over here, right there, minus 11, and over here, oh, there we are. Phew, I thought I found something from that there. Minus 11. So it's minus 11 everywhere, is it? Let's just double check again. It's going to get there. Minus 10. Stop moving. Ooh. My imagination is my light flickering over here. What happened there? So I just kind of these sockets are leaking. sound too good. That's me tapping one of the tubes there. That's my tube. That's my tube from my my collection. I'm stopping because my light appears to be flashing over here. No, it's going on its own. So I found that LED lights are really sensitive to slight variations in the supply voltage in your house. So your house voltage is always bopping up and down a little bit. And I find some LED lights anyway, you can see that. It's very annoying. I think the lights are extremely fast compared to a hot filament, which is extremely slow in changing temperature. That's that too. I'm going to put a different tube in there. That sound to me suggests there's elements inside the vacuum tube that are loose and moving a little bit and vibrating, springing, bouncing, and it just doesn't sound like a good idea to me. Let's take it out of there. Since the original tubes are all testing fine, there's really no reason to not continue with the original tubes. Okay. Well, that sounds pretty different, doesn't it? Man alive. Now, I've been fooled before. Let it warm up. Now this is humming without the two preamp tubes in. They're sitting over here. Much louder hum. What has happened? There we go again. Either I don't know. So we're on voltage 20 volts. So that's fallen to a 0. Kind of a 0. Kind of. So changing the tube has caused this to be different. Shouldn't be anything here. Did I just say there shouldn't be anything there? Yeah, there should be B+ coming through there. I'm like crazy now. Like crazy. Doesn't do anything, of course. Screen 320, 328, extra 8 volts there. 325, 330. So these should all be the same here. 331, pretty well the same. 325, 327. It's a little higher. Less current flowing. Less current flowing would mean less drop in this resistor. So we're going from 330 to 330. 325. 325. There's still no current in this. No current flowing. The hum is clearly in one channel. Switch tubes back. You know what? This tube that's humming, I don't think it's as hot as the rest. I don't think it's as hot as the rest. These are burn your hands mercilessly hot normally. Okay, very quickly take a peek. And that's the case. This tube is not as hot as the rest. You gonna believe me on this? Interesting, it's just not coming across on the screen at all. Huh, it is. Well, I don't know what's happening with the camera here because there's bright red on here. This tube is nowhere near as hot as the rest of them. Nowhere near. Ta-da. Okay. Welcome to my world. My world of massive craziness. I tested these tubes while I was working on the computer file problem. These tubes test just like new. Both of them test identical. No sign of any leakage in them whatsoever. I used my Weston tube tester, which I think can show leakages between elements much better than the Stark tube tester. So the two tubes are back in. What do you say now, Mr. Amp? Supposed to say nothing. So, I don't know if you heard that, but I clearly heard the hum go up and down as the unit's warming up. Then I heard the hum fade out as that oscillation came in, as if the oscillation is replacing the hum. Still a little bit of hum there. Here we go, are you ready? Everybody. This is the grid to plate connection, the gain. It's supposed to be 34. Ah, come on. Look at that, 34. It's the first time I think I've ever actually seen 34. I think it's supposed to be 34. So this test measurement I'm doing now is never consistent. What happened there? So now the amp is dead silent. There's no hum at all. No squeal. Is there actually? Is this? Oh, the hum tried. I can hear it. Okay, that was interesting. So I heard the hum kind of clicking on and off there. Who are you? The hum is really hard to believe. The hum is an oscillation like the other. I don't know. So $30, $15, $30, $15, $30, $15. Are you seeing this? You are seeing this, right? 30, 30, 30. This one's always consistent. It's this guy that flops around. It's a flip-flop. I still remember as a kid getting an electronics magazine, and on the front cover was a picture of two tubes wired together into a flip-flop. And the explanation in the magazine was how this flip-flop circuit with these two tubes was the key to computer operation. There you are. That's what I got here. I got a flip-flop. It's 30. 30. Not anymore, I don't. I am the flip-flop. 30 and 30. Did I see the 15's over here now? Did I see that? 30. 30. 30. 30. Well, at least I got some video here to post. I'm going to post this, and then I'm going to pay attention to comments and other helpful things that might come my way. Wow, I cannot fathom this at this point. I just can't. I don't know where to go with this whole thing. Okay, I think that's it for my shop day here. You know what, I'm going to find myself back in here in the afternoon because the curiosity is just killing me on this. So thanks a lot for watching this part. Sorry this whole series is being kind of broken up and smashed, but oh, time to go back to work. What just popped? First of all, is this thing working? How can I tell? So it's tricky to tell because I have shorts on the grids. Oh, here comes the tone now. I don't even know what to look for. I don't know what to test. Help me, man. I've lost my mind on this. $33 now. This connecting a plate of one side of the triode over to the grid of the other triode, it just makes me so uncomfortable. I think we're seeing the effects of that, but I don't know that that is, really the problem. That's not. This stick has paid off so many times. Why do I keep putting it down? Or just keep beating it? So there is a grounded soldered terminal right here. If this grounding is failing here, that would cause the impedance of the grid connection here to go much higher yet from what it is. Because right now it's 1,000 through a capacitor through the 68 to ground. Some trouble flexing this. Sure seems solid to me, boy. But I whacked this. Leaking through these. Is it possible there's a leak through these? There's almost no voltage here to leak across. I whacked it hard last time. This is what it's down to. Caveman repair. Beat it with a stick. It's pretty consistent now, isn't it? Is anything getting hot during this whole process here? So I'm feeling the output transformers. Interesting. Let's take a look at that situation. So I can't read the current easily in these circuits, but the heating effect may be a little more apparent. Try my viewer again. I apologize once again. The image is not coming across on the video very good. So now, oh good, you can see it now. Let me get in a little closer. So this is one tube, next tube, next tube, last tube. Can you tell that it's less hot? So that is reading about 130 in the red spot, and this one's reading 290. Oh my gosh. 290. 290. 230, 2 anything, 2 anything, but this one 130. So this is running way cooler. Just to add to the whole craziness of this thing. Oh yeah, I was going to check the output. So again, I apologize for these images not being very good. So in this view, so from here, and I know you can't see this, this suggests this one's quite a bit hotter here. It's definitely hot. It's almost uncomfortable to do that. This one's cooler for sure. There's no question. Of course, this guy's busily feeding these two hot tubes. How are they getting hot? They got to get their power from somewhere. It's coming through here. Now, this guy's feeding these two tubes. Only one is hot. So he's not as hot. He's not working as hard. The end result is the current operation, I'm sure, is not correct. These have to be too hot, I have to think. Oh my gosh. In fact, they're burning up right now. Burning up, Jim. Turn them off. The weird thing about this is I have repeatedly measured the voltages on each of these tubes. The plate and the screen. They're always the same. Very close. I've also taken the output transformer as best I can, the two of them, and I tested with resistance through the windings. They are consistent, and there's nothing there that makes me think there's an open winding or a shorted winding. They're quite consistent. Shorted winding to the output winding, like from the primary side of the transformer around to the secondary side. I never looked at that. How do you do that? Let's try that. That's something I've never tried. And I'm game for more confusing information. So what I expect to see here is basically an open circuit between the primary and the secondary side of the output transformer. Pick any primary lead into it. So this would be the I got this right, am I talking about? It's an output, yeah. So the primary side is coming from the tube. The secondary side is on its way to the speakers. It's got to be happening in here. Man, that's where the feed. How can this be the output and the feedback and everything? minus, so we can't believe what I'm seeing on the meter right now. Better place to measure it. So we're looking at the secondaries and then the primary for sure. It's coming out. It's coming out down here. Two, three, four. There should be two more coming out. Looks like there's three more coming out. Here's two more over here, heading out. So these are them. So this is the secondary. I say open circuit. Yeah, that's this one. I got the other one to check yet. So that's how to check it though. So the other output transformer wires, got to make it over there. Got to make it to, gonna make it here. Why did I think these were twisted brown wires coming back? Red wire here. Red wire is coming from the B plus. So this will be the center tab of the primary side of the output transformers. It looks like one here and one here on these wires. That's what's going on here. I take this and then connect it to the what I think is the output. I'm not sure anymore. Output should really be coming to these speakers. So everything's speaker terminals are here. Oh, don't knock it over. That's 13 megohms, 14 megohms, and here the other one, we test both at the same time. 11 megohms. Short between the primary and the secondary side, the output transformer is not existing. So I've done all kinds of comparative resistance tests where I've just put the ohmmeter on ohms, put it on 2 million. Well, then I just start comparing. I check here. Okay, so that gives me a reading of 80. And what do I get here? 80. That's an 80K resistor right there to the chassis. I'll go here. Wait a minute. That's supposed to be there. I guess so. How does that get there? 370,000 ohms. This is just a grid connection here. Is that something I'm not thinking of? I thought these were basically isn't this the grid? Pin number 2? It has to be the grid. It is. Pin number 2 and pin number 7 are the grids. I just looked at the wrong tube. I looked at the wrong tube. Okay, so pin number 2 is also the grid of the 6 BQ5s. So it is definitely a grid. It has to be the grid. So how do you get that kind of reading? Here. Pull the tube out. It's cooled off. Out. How's that happen? Oh, what? Okay, for sure I pulled the tube out. There's no tube in the socket. This pin goes nowhere. How do you get that? That's across the resistor. Wait a minute, where'd that come from? It's across the capacitor, rather. You know what this is kind of coming down to? Leaky or conductive terminal strips. Is that in any way possible? They look fantastic. Well, how do you get a resistance there? And how come it's consistent all the way across? Let's see if it's consistent. 215. $450. Two. So I think every one of these readings should be open circuit. I'm reading across a capacitor. Let me just get the image on my screen here. Make sure you're following along. Yeah, so I'm reading across a capacitor. This part of the link just goes to a resistor to a grid on a tube, like over here. And what I'm saying is there's nowhere for current to pass. There's nowhere to get that reading, and it's not consistent. Can it really be the terminal strips? I think I've encountered one conductive terminal strip in all my dealings. It's not something I look for though, so I may have overlooked them quite a few times. Well, let me put the ohmmeter right on the terminal strip itself. I can pick on a terminal, like a metal terminal, and then I'll just touch the this is the stupidest thing I've ever done. Oh, for God's sakes, there's resistors under there. I forgot about. Oh, for crying out loud. Call me a bozo. So, okay. Oh, man. That's the stupidest thing. Because I think I mentioned this on a video not posted. When I stand here, the resistors that are under here are absolutely invisible. Nothing of them shows up. It's because there aren't any there. They're up here. Same thing up here though. You can't tell there's resistors under here. Okay, I got something. What do we got? What do we got? What do we got here? Okay, so they're all look like 330 ohms, 330K. Exactly what I've been reading this whole time. 330K. $330. A little high. So there is a connection of the grid to ground through basically 330,000 ohms. I whacked it. Did I whack one of these resistors? I whacked this terminal and the resistor's right on it. Okay, we're going to fire this guy up again. I'm going apply the stick. Where's the hum? There it is. Patience, Jim. Hand on the chassis. So all we have is the hum now. There's no squealy stuff. And I got one tube out. Okay, hold on. Bogus test. One tube out. Test on again. I'll wait for the last tube to warm up. So, the tube I just put in was here. This is the tube not running hot. Or this is the tube running cooler. Okay, I'd say we're in business. No squeals. Everything's solid as can be. And this is a well-built amp. Now it's operating in a steady state condition now. A hummy condition. What was that? Light going up and down? I'm just losing consciousness. That's really what's happening. Here we go. Grid the plate. 30. Grid the plate. 15. Grid the plate. 15. 16. Grid the plate. 30. 30. Gosh, didn't I stop earlier? What am I doing still going here? I thought I stopped earlier. Okay, we're going to take a look at the scopy thing here. What kind of oscillations are visible while this hum is a humming? While the hum is a humming. Okay, right on the output of the output tubes, right on the plate of the output tubes. Slow it down one notch. No RF. Screen. Just the hum. No RF. That hum looks identical to what was in the power supply. No RF. Huh. On the other channel, RF. Plate. Oh, look at that. So that's the plate of the right hand channel. That's the plate of the other tube in the right hand channel. The left hand channel, the plate is clean. Holy cripe. Ah. Capacitors all around. Stick capacitors in everywhere. See a signal you don't want? Stick in a capacitor. Get rid of that signal. I really don't know what to do. I really don't know. I just want to get rid of the hum and move on. Holy smokes. Well, thanks a lot for watching this another really difficult video. Man alive.